Hello and welcome to Technical Interview Preparation, Large Language Models, and Generative AI. I will be doing a series of questions and there will be three responses. Number one, what is a large language model and what key technology enables their performance? Response. A large language model is a neural network that uses deep learning algorithms. LLMs are trained on massive datasets and are ideal for use in other AI projects. Large refers to the immense number of parameters involved, often in the billions, and also to the scale of the training data, with tokens often measuring in the trillions. Transformers are the key technology involved in large language models. Transformers are powerful neural network architectures that excel at processing sequential information using a self-attention mechanism which weighs the importance of various parts of inputs. This weighing of the different parts allows models to understand context and relationships without sequential processing and represents a major breakthrough in AI technology which powers models like ChatGPT and Gemini. Transformers were introduced by Google in 2017. Prior to this, parallel processing was the most feasible solution, which required functions to be run linearly, which is much more time consuming and limiting of large datasets and parameters. In short, large language models are trained on massive datasets using deep learning algorithms that run through computerized neural networks, wherein inputs are processed by transformers which use self-attention mechanisms that enable computerized contextual understanding and responsive artificially intelligent output. Question number two. Explain the concept of prompt engineering and why it is crucial for large language model deployment. Prompt engineering is the systematic process of designing, refining, and optimizing inputs, or prompts, to guide an LLM to produce a desired, accurate, and relevant output. Prompt engineering is crucial for LLM deployment as it provides structure for model learning. LLM performance is highly sensitive to prompts. Prompt engineering narrows the scope of focus, which allows more in-depth responses as opposed to generic and ambiguous responses. If you wanted to have a model that talked about finance and the prompts were based on nature, well, that might not yield the best results. A helpful way to think about prompt engineering is that you are programming a model with natural language instead of code. You're using your language to write the specification and runtime constraints that the model executes, effectively making the natural language prompt the program itself. Hence NLP, natural language processing, not neuro-linguistic programming. It's another video. Um, next, we'll talk a little bit more about that. An effective prompt engineering leverages several core techniques, and I don't know that I'm going to have a ton of time to get into all these, but we'll see. Instruction tuning is the foundation wherein the model is fine-tuned to follow specific directions, and as we said, the quality directly relates to the output, the quality of the prompt, that is. System message, this hidden initial instruction sets the overall context, persona, and constraints for the model throughout the entire conversation. For example, you tell the model that you are a Wall Street executive. Um, in context learning, which instead of updating its internal weights, ICL allows the model to learn new tasks directly from examples you provided within the prompt itself. And few shot learning is a specific type of in context learning wherein you can provide a few input and output examples to the model with the prompt to design specific patterns before asking the final question. Many styles. Output control involves specifying the exact form of the desired output. That is, respond only in JSON or use a bulleted list. And iterative refinement is rarely a one prompt engineering, is rarely a one-shot, one-and-done process. It requires iterative refinement where the prompt is continually tested and modified based on the quality of the previous outputs to reach the optimal instruction. But you wouldn't know nothing about that, young man, unless you would. or that's not what your gender is. Moving forward, what is an embedding? Give a concrete example of a prompt engineering task you solved using the STAR method. First of all, an embedding is a dense, low-dimensional numeric vector that is a list of real numbers that represents linguistic units, such as words, phrases, documents, pictures, etc. It's a crucial function to capture the semantic meaning and context of the text for the model. And vectors exist within a vector space, wherein the geometric distance between two vectors is directly proportional to the semantic relationship between the corresponding pieces of text, often referred to as semantic similarity. Key characteristics of embedding are that there's dense representation, unlike older sparse representations. Embeddings use every dimension of the vector to store meaningful information, making them highly efficient, as opposed to one-hot encoding. Um, Contextualization is another characteristic, as the numbers within the vector represent learned features of the text, and that saves time. Embedding plays a critical role in almost every natural language processor and large language model application. Uh, that is to measure similarity as well as for RAG, or retrieval augmented generation, which is one of the most important functions, wherein a user query is first converted into an embedding, and then that query embedding is then used to search a knowledge base or vector database to retrieve the most semantically similar text chunks. And these retrieved chunks are then provided to the LLM as context, which reduces hallucinations and allows the LLM to access up-to-date information. Now, a time where this happened with me and I had to use iterative refinement to solve a problem, let me share a story about that, and I'll be quick about it. We're at 7 minutes. We were working on a system that used LLM to analyze and categorize transcripts of tech support calls. The output needed to be consumed by other automated tools, so the model had to strictly adhere to a JSON schema for easing parsing and database entry. The prompt resulted in two issues. There were JSON errors, causing it to pass or fail, and there were also inconsistent categories. So I implemented an iterative refinement approach using two key prompt engineering techniques. The first, system message for strict output control. That is, I added a clear and mandatory system message at the start of the conversation that strictly defined the output structure, making sure that to tell it you're only JSON, don't you try that. And number two, few-shot learning for taxonomy. That is, to reinforce the numeric ID output, I used few-shot learning by including a small dictionary in the prompt's main infrastructure, defining the accepted categories. And I gave three specific examples of this. The result was a dramatic improvement in reliability. After implementing and testing this refined prompt, the scale or the rate of successfully parsed and valid JSON outputs increased from 65, which isn't good, to 98%, which is way better. Also, the categorical adherence, using only the correct numerical IDs, increased to 99.5%. And by using a combination of strict message and few-shot learning, I essentially programmed the model to act as a highly reliable function, which enabled seamless integration with our downstream automation tools. Thanks for watching.